Hello, today in this tutorial we are going to see how we can implement streaming response in case of Spring AI application, which will make our apps look more interactive as well as responsive. So consider an example wherein you are trying to build the chatbot for your website. Now once user submits the question to the chatbot, the response from chatbot should appear word by word in real time rather than waiting for the entire response. This is known as the streaming effect, which makes our website looks more live as well as responsive. So this was regarding the basics of streaming. Let's see how we can implement this in our use case, for which we have built one simple app which will generate the recipes based on the dish name submitted by the user. So when it comes to our application, user can request for recipes and they will provide the dish name as well as the serving size as an input, and instead of waiting for the entire response, they will see the ingredients or steps that are generated by the AI in real time basis. So coming to the project structure, the name of the project is Spring AI Streaming Response, within which we have one controller class, we have one service class, we have Spring Boot main class, then we have the application and pom.xml containing the project configuration. Now let's jump to the IntelliJ. So here you will see the structure that we discussed is also present here. So when user submits the request, it goes to the controller. Controller will forward it to the service class. Service class will interact with the LLM. And once we have received the response from LLM, it is returned back to the controller. Controller will return it back to the client. Let's see each and every file in more detail. Starting with the pom.xml, here you will see we are making use of the Java version 21, and Spring AI version that we are making use of is 1.0.0, which is the stable version. Then we have added two dependencies. First one is the Spring Boot starter web, which is useful for developing the REST APIs. Next dependency that we have added is Spring AI starter model OpenAI, using which we will be interacting with the LLMs, and in our case we will be interacting with Google Gemini APIs. Then we have added the Spring AI BOM dependencies, which is useful for managing the Spring AI related dependencies. Coming to the application YML, here we have added the configuration that is required for interacting with the LLMs, for which we have added spring.ai and we have configured the API key. In our case, we will be receiving the API key from environment variable. Then we have the base URL. Since we are going to interact with Google Gemini, here we have configured the domain, or we can say host, as well as the base path. Then we have configured the path suffix, which will be appended to the base path. And the model that we are going to use is Google Gemini 2.0 Flash Experimental. Now coming to the controller class. So here you will see we have defined the base path for our APIs, which is /API/recipes. Then in our controller, we have defined the two simple endpoints. First one is the get endpoint /generate, which will generate the recipe based on the dish name submitted by the user and the serving size. And another endpoint that we have is generate recipe with metadata, which is also a get type of endpoint, and the path suffix is generate with meta. This is also similar to the very first endpoint. The only difference is the response from this endpoint will contain some additional metadata, which we will see while we will run our application. Now, when the request is received by the controller delegate this request to the service class, within which we have the generate recipe stream, and whatever input we have received from the user, we will provide it to the service class. And when it comes to service class, we have wired it using the constructor injection, for which the configuration is mentioned here. Now coming to the service class, since we have two endpoints, we have defined the two methods inside the service class, which we will go through it. But before that, let's understood what else we have defined inside the service class. So at the very top, we have the chat client, which is useful for interacting with the LLM, in our case Google Gemini API. Now we need to initialize this chat client, for which we are making use of constructor injection and the chat client builder, which is provided by the Spring. and all we are doing is we are just calling the build method on the chat client builder, which will be useful for initializing our chat client. Once the chat client is initialized, we can interact with our LLMs. Now coming to the first method, which is generate recipe stream. So this was called by our first endpoint, get endpoint, which was slash generate. As an input, we are receiving the dish name and the serving size. Now based on these two inputs, we are creating the prompt that we will send it to the LLM. So the prompt is very simple, that we need the step by step details or recipe information, for which whatever input we have received, we are passing that input inside the string dot format. And then once the prompt is ready, we are making use of chat client, within which we will pass a prompt here, and then we will call the LLM and we will request the LLM to send us the response in the streaming format. And since we are only interested in the content that is generated by the LLM, due to which here we are making use of dot content, which will only give us the content or the recipe instructions that are generated by the LLM. Now when I say we are only interested in content, which means whenever we get the response from LLM, it contains certain additional metadata. So here we are ignoring those metadata or additional information. We are only interested in the recipe instructions or steps that the LLM has generated, based on which we are calling the dot content method. Now if you see the return type of dot content, it is flux of string. So it will contain the string and it will wrap it inside the flux. Now when the response, once the response is received from the LLM, it will be returned back to the controller, and inside the controller as well you will see the return type is flux of string, which is nothing but it will send the response in the streaming format. Behind the scenes, Spring Web Flux is automatically sending the data in the streaming format to the client. And coming back to the service class, so we covered the first method. Next method is generate recipe with metadata, which is called by our second endpoint. So here also you will see the overall approach is similar, wherein we are first drafting the prompt, then we are calling the LLM and we are requesting the data in streaming format. The only difference is, instead of calling the dot content method, here we are calling the chat client response, and the return type of this is flux of chat client response. Now inside the chat client response, apart from the recipe content, we will also get certain additional metadata, which we will see shortly, due to which we have just created one sample endpoint so that we can see what all metadata we get if we are interested in that metadata. So now we covered the controller as well as the service class. Let's start our application and see our application in action. Now our application is started. So we will make use of the curl commands to call our endpoint. So first we will call the slash generate endpoint, for which here we have specified it as curl, then -n, which will disable the buffering so that we can see the response, the streaming format in real time basis. Then we are calling the API slash recipe slash generate endpoint by passing the dish name and the serving size. Now if we send the request to our application, you will see we are getting the response in the streaming format. So this was the first endpoint. Next we will call the meta endpoint, wherein we need to specify one additional header, which is accept, and then we need to specify the text slash event stream, which will request our application to send the data in the form of server side event. So here the endpoint is generate with meta, then we have specified the dish name as well as the serving size. Now when we will send the request to our application, here you will see we are getting the data in the JSON format. And one additional thing to note here is all the streams, or we can say chunks, are prefixed with keyword data colon, which is the standard for the server side event. And here you will see, apart from the content, recipe content, here we are getting certain additional metadata as well. Like for example, here you will see the output is sent by the assistant, which in our case is Google Gemini, here the recipe content is present, and when you see the final chunk, you will see the finish region is mentioned as top, which will denote that the streaming response is completed. So this was regarding both the endpoints. Now if you have to test both the endpoints using Postman, what we need to do is, first we need, while calling the endpoints, we need to specify the one additional header, which is accept, and the value of this header will be text slash event stream. So let's test our first endpoint, which is generate. So here you will see when the accept header is specified, we are getting the response in the streaming format. And once we remove this header and call the same endpoint, you will see we are not getting the responses in chunks. Here it denotes the request is getting processed, and once we have received the full response, then only the response will be displayed here, or we can say the response will be sent back to the client. So this was regarding the first endpoint. Similarly, if we have to check the second endpoint, then again we will specify the header, and once we send the request, here you will see we are getting the responses in chunks, and the response is in the JSON format. If we click on any of it, you will see in the here some additional metadata, like the response is sent by the assistant, the text, or we can say the recipe steps that were generated by the LLM are mentioned here. Also you will notice there are certain additional metadata like related to rate limit. Now in case of our Google Gemini APIs, these values are not getting populated, but if you use the OpenAI APIs, in that case you will see that you are getting the actual values in object. So this was how we can also test our APIs using Postman. Now if you have noticed one thing within our application, the response type in controller is mentioned as flux of string, but we haven't added any Spring Webflux related dependency inside our project. This is because the Spring Webflux dependency is coming from this particular dependency, which is starter model OpenAI. And if you have to cross check it, we will go to the dependency analyzer. We will mention the dependency name, which is Webflux. Now if we click on it, here you will see this dependency is coming from Spring AI starter model OpenAI. So that was all regarding streaming responses. For this we have also written one detailed blog wherein we have covered some additional concepts like chunked response or chunked encoding server side event. So you can go through it if you are interested. Also the example that we have covered in this tutorial is uploaded on GitHub. You can check out and try the same. So yeah, that was all from my end. I hope you found it. Thank you.